Okay, here's the answer key for the medium page. All right. Describe the motion of the object. Be specific. Include what times and positions the changes happen and the velocities in each intervals. Okay. All right. So the first thing I see is the object is stopped. All right. In this flat part. Okay. And from here to here, I'm going 2 seconds, 40 meters. Okay. So that's going to be a positive 20 meters per second speed. Okay. 0 in this interval. Okay. And here I have about 1.5 seconds and negative 40 meters. Okay, so that is going to be negative 26.7 meters per second. So slightly faster than on the way there. Okay, all right, so then I would say the object begins at rest. Okay, sometimes we say that at rest or not moving. All right, we don't really know. Oh, actually we do. Begins at rest at 20 meters, okay? Then moves, hold on, I should add the time, for 1 second, okay? Then moves in a positive direction at 20 meters per second for 2 seconds. Then it stops for 1.5 seconds. Finally, it moves in a negative direction at negative 26.7 meters per second for 1.5 seconds. Okay, so something like that. All right. What is the velocity during the time interval 1 to 3 seconds? Okay, that was this one, 20 meters per second. Okay, so 20 meters per 1 second means for every 1 second, the position increases, because it's going in a positive direction, by 20 meters. Okay? What is the object's position at 2.5 seconds? So position, I'm just simply going to read from the graph. So 2.5 seconds is halfway here, okay, which looks about halfway here, which is going to be about 50 meters. Okay. All right, and then what is the total displacement for the whole trip? So remember, we're just doing final minus initial position, and we don't care about any of the rest of it, okay? So it ends at a position of 20 meters, okay? And it started at a position of 20 meters. So really, this guy went nothing, okay? Really didn't go anywhere at all, okay? All right, calculate the slope, show work, and write the math models. Okay, this is really important because this is kind of what was on the mild page. So make sure you got these right, okay? If you didn't, then you need to go back and do those, okay? All right, so let's do the red guy first. Okay, so that's going to be 0, 2, and 2, 7. These numbers are pretty easy. Okay, so that's going to be 7 minus 2 is the y's, 2 minus 0. So that's 5 meters in 2 seconds, but we just want to make that a decimal. Okay, 2.5 meters per second. So it's going to be xf equals the slope, 2.5 meters per second. Make sure you have the right units, times the x variable time plus 2 meters, because that's where it started. Okay, check the units, make sure that's all right. Okay, and then blue, let's do 0, 6 and 4, 0. Okay, so my y's, 0 minus 6. My x's, 4 minus 0 is negative 6/4, which is negative 1.5. Okay, so my final is going to be x final, negative 1.5 meters per second. That's the slope, times the time, plus the initial position. Okay, so check those and make sure they're right. Okay, make sure all the units and everything is good. Okay, who's going faster, red or blue? Okay, so red is going faster because the slope is steeper. Okay, it's covering more distance every second, right? It's covering 2.5 meters every second, where blue is only going 1.5 per second, okay? Who went further in the first 4 seconds? How do you know? Okay, well, 2 ways we can look. Okay, we know it's going to be red because red is faster. So given the same time frame, it will go further than blue. Okay, that's one way that we know. Okay, or if you want to look at the graph, you can see in 4 seconds, oh, we can't even see where that one is. Okay, blue went that far. Okay, blue went -6 meters. Okay, and red went 5, 6, 8, 4. I mean, it's going to be like way up, like here somewhere, right? So it's going to be like 8, 10, 12, like way further. Okay, like about, I don't know, 12, 4 seconds, or 10. Be more than 10, wouldn't it? 2, oh wait, 6, 4. Okay, all right. So in 4 seconds, right, red is going to go 2.5 meters per second for 4 seconds. Oh yeah, it's going to be about 14. That's what I thought. Okay, well, it's going to be at 14. Okay, oh, I know why I drew this wrong. Hold on. I was so confused there. 2 up. Okay, so it's going to go 10 meters. All right, in that same time. Okay, so if it started at 2, it's going to end up here at 12 somewhere. Okay, all right, and what is happening at the intersection? All right, they are meeting or passing each other. Okay, and that will happen at a time of about 1 second. Uh-oh, what happened to my thing? Oh, my pencil just died, dang it. Almost done. Okay, they'll meet at a time of 1 second and a position of about 4.5 meters. All right, so you're looking at that point where they cross, okay, and you're reading off that intersection point. That's going to be important for the summative assessment. Okay, so they're going to meet at time equals 1 second and at a position of 4.5 meters. All right.